We are finally ready to train our classifier. I've chosen to go with random forest, although in practice you will want to test out different classifiers and see what kind of results they give you. Some problems are solved well by random forest, other problems are solved well by gradient boosting, and other problems still may be solved better with neural networks. Only experiment will tell you which one really performs the best. Once I have chosen my classifier using scikit-learn, I'm going to fit it to the transformed training set, and then I'm going to predict on the transformed testing set. Now you see that my predictions are all 0. In other words, the classifier predicted everything to be benign. And the reason for this is that my dataset is highly imbalanced. The ratio of benigns to malicious is close to 20:1. Therefore, in order to get high accuracy, you can simply label everything as benign. Such problems are actually quite common in cybersecurity. It is usually much easier to have benign samples than it is malware. At the same time, you'll actually encounter situations where the exact opposite is the case. For instance, your company might not be allowed to keep the benign samples due to privacy concerns. Then you'll have an imbalance going the other way. Another important consideration is that there might be sensitivity to one type of error that is greater than to the other type of error. For instance, you might be more concerned about your customer being frustrated that you are mislabeling benign samples as malware than you might be about letting some sort of malware through. Or perhaps you're more concerned about the other way around. To use other terminology for this issue, you might be more concerned about false positives, cases where you label a benign sample as malware, than you are about false negatives, where you label a malicious sample as benign. Both of these are very important considerations, and we'll see how we can try to tackle them in the next video.